Hello everyone, I'm Thiru, developer at LazAI and Metis. In this tutorial, we're gonna see how we can able to mint DATs and do private data inference using LazAI and Alith SDK. We're gonna start with going to the docs of LazAI. I'm gonna share the docs here. So here you can see the data contribution workflow here. We just need two keys. One is the private key and with sufficient LazAI tokens and the IPFS JWT. For this tutorial, we're gonna use Pinata. So you can use any other service as well. And the implementation can be done through Rust, Python, or Node.js. In this tutorial, we're gonna use Python. And I also have a repo which provides all the uh, commands end to end along with the script. I'll share that here. So this repo in LazAI GitHub, it contains the prerequisites along with the setup instruction and instructions to run the scripts. We'll first clone this. I'll share my terminal. So you can see my terminal here. I'll open I have created a folder, and then I'm gonna clone this repo. And once I cloned it, I'm gonna open it in my code editor. So I'll check. So I'm inside my repo folder here. So the first thing we have to do is to check the prerequisites. First is have the Python with version 3.8 and higher. The current Python version I'm using is 3.12.11, so you can also use the same. And the private key of LazAI. So LazAI is not like wallet, so you have to create a MetaMask account and export your private key. And for the Pinata IPFS JWT token, you can create the account in Pinata and get your JWT token from it. And here for the testnet tokens, which is required to sign transaction, you can get it from the faucet over here. We can start with setting up our environment. Yeah, just to check whether the recording is going on. I hope it is. I'll just quickly check my mic as well. Yes, it is recording. Cool. Yeah, let's get back to here. We have set up our environment. The next step is to activate it. I have activated my Python environment. I'm gonna install Alith. Yes, it also installed the required packages for Alith. And the next step is to export private key and IPFS JWT. Before we export our ENVs, I'll take you through the DAT script. So we have the necessary imports. Oh, we are on the right. Yes, I'll quickly do a reload. Yep, yep. Packages are not installed. We are inside the ENB, and the Python packages should be installed here. Yes. Okay, there's a issue with the Alith command. So you can check the Alith over here and install this command. So once you have installed it, you can able to run the DAT, and we have the required modules over here, and we have the privacy data. This is the data that we provide to the LazAI and mint a DAT for it. So we have some hard coded data regarding a agent and LazAI, and followed by we have a main function which will be executed from the class. So this main function have a client instance and IPFS instance. We are providing a data file name, so I'm gonna just make it as a static um, data, and this data is being hashed, and we sign a message, and we also encrypt the data and upload it in the IPFS. So here's where we get the IPFS JWT token that we're gonna export in the envs, and we upload it. Once the upload to IPFS is successful, we will receive a URL. So this refers to the pinata URL. With the URL, we will get the file ID. So once the file ID is retrieved, we will sign the transaction. So without further ado, let's run this. Yeah, I forgot to export the private keys. So I need to export private key. It should begin with 0x, because when we export the private key from MetaMask, it usually don't have 0x. I'm gonna stop sharing my screen and quickly export private key. I have exported my private key, and I'm gonna export my IPFS. Yep, yep. So we are back to the tutorial. So in my code editor, you can see I have already exported my envs. I'm gonna run DAT now. So I accidentally showed my private key, but it is a test key, so I don't have to worry about it. But you don't never expose your private key anywhere. So here, there's an issue with like existing version of uh, Alith. So if you install the most recent version, you won't have this issue. So if I go over here in the ipfs.py, I just need to do a minor change. Here I just have to make this as false. That's it. Now if I run DAT, so this executes the encryption of data and upload the file to the IPFS and mint the DAT. So we receive the file ID. So this file ID is essential to do the data inference in the next part. So we have successfully minted our first DAT. Now we're gonna go to the inference.py. Here it have the import of agent and LazAI client module, and The LazAI IDA address is the address that is associated with the inference server running in a AT client, mostly on a GPU and like Fala or Merlin client. So this is the one that we have for the demo purpose. This is running in Fala CVM client, and we have a deposit amount. So this is a fee to do the inference query, and we, for the debugging purpose, we are printing our wallet address. So where this wallet address is coming from? So this is coming from the private key that we have provided, and here uh, we are getting the address and passing it to check whether this is a existing user or a new user. So if it is a existing user, the except part will be skipped and then it will go to the next block. If it is a new user, the address will be none, so the except part will be executed, and here we call the add user to add. So the add user will be executed only once per user per address, and we will do the deposit function to the LazAI client and deposit inference function to pay the query fee to a particular inference server provider. So basically the LazAI IDA address, because there will be multiple inference servers. So for each provider, when we run query, we have to pay them. So this is similar to how blockchain works in general. In order for the node providers to run the node and process our transaction, we pay a small fee in gas. Similarly, in order for the inference server provider to process our request, we pay a small fee, which is using the deposit inference. And once these functions are executed, we are providing our file id. For us it will be 1 to 1, and with the file id provided, we will first get the url by passing the LazAI IDA address in the get inference node. So this LazAI IDA address is associated with the server running as a provider, so the server will have a url. With this function we will retrieve that url, which we will use in the later part. And we have the get inference account check. So why we have this is to check whether we are authenticated to run the inference query. This get inference account function will return a list of accounts that is authenticated by the inference server to run the inference query. How we can get it is by passing the address along with the particular inference server address, and it will print the inference account. So if our wallet address is within the inference account, which means we are authenticated, otherwise the account will be none. So we can check the print statements to check whether we have the inference account or not. And we are creating an agent instance by passing the model. So this model have to match with the model that is running in the inference server within this url, otherwise it will throw an error. Let's say the inference server is running with the OpenAI GPT-4 model. If we pass DeepSeek, it will obviously throw error. So how we can check is by going to the docs. You can check whether uh, the model that is being used by the particular LazAI inference server. Based on that, you can able to pass the model over here, and you don't have to change anything with the base url. So the base url is basically the inference server url with the v1 endpoint. And we also pass the extra headers, because you can simply use this agent kit to build your any type of on-chain AI agents. But in order to run the inference query particularly, you have to mention the base url along with the extra headers to provide the context. The context is to reach the this particular IDA address where the inference server will be running, and the particular file ID for the context. And we have provided all this, and then here we're gonna give a prompt. So I'm gonna give the prompt, summarize this data. So we have already provided a data over here, which is the data on Alith, we're gonna summarize it here. So we're gonna ask uh, the server to summarize it. How we can call it is, I'm gonna first clear this, and Python inference.py. It first fetches our wallet address. The user is already exist, so it fetches the URL directly without going to the deposit process. It fetches the inference account. Now we are waiting for our response from the inference server. So this inference server is currently slow because it is in a Fara CVM instead of GPU. So usually the inference server will be GPU, so it won't take this much of time. The response will be spontaneous. Yep. So we have our response here. So it contains Alith AI agents and summary of it with core purpose, key addresses, and Alith's key features. So if you provide your data again and you will receive a new file ID, you have to change it over here. And if you are querying a existing file ID also, you have to you have to change it and then send your query over here. So to mention that, you can query a single file at a time. You cannot send it as a list because the type accepted over here is a literal and not a list. So that's the reason. You can do it like one by one, or like a different thread with same address or different address, so that you can do parallel processing as well. And with this, the tutorial on DAT minting and inference query on private data inference is completed. We will have a similar tutorial on TypeScript as well as Rust, because you can execute the same implementation in both Node as well as Rust framework. So we will have videos on that as well. And to mention it again, there's like only few things you have to change with the script. One is the file ID and the prompt that you are sending. Yep. Cheers. Bye. Yep. I'll see you on the next video. Cheers. Bye.